All right, now we're going to continue on talking about research design. So it is very important as you guys are going through the DNAP program. You're gonna see this evidence pyramid numerous times, and you'll see there's slight variations in it, but this is essentially kind of the pyramid of evidence, meaning as we go up, there's increasing clinical relevance of the findings. Um, So the studies at the top with randomized controlled double-blind studies are the most rigorous studies with the tightest control. Systematic reviews and meta-analyses typically will take RCTs and they will synthesize the results of those studies and quantify effects, and that can help. One of the problems sometimes with randomized control trials is that many times they're underpowered, and so what they do is they can pool studies of similar design and outcomes, and come up with a composite result uh, that of what a true effect is, or at least a potential true effect is. Another way to look at an evidence pyramid is where you might have at the lowest level qualitative studies, expert opinion, theory, and basic science. Then you can have non-experimental studies. Then you can have experimental studies, randomized controlled trials, and then evidence summaries, such as systematic reviews with or without a meta-analysis. Here's some more categories of hierarchies of evidence, as well as the relevance or usefulness of the evidence. And you'll see these. This is actually in Dr. Biddle's book, and many times when you read research articles, some articles will actually list the level and level of evidence, as well as when say the Cochrane collaboration is looking at studies, they may also look at its relevance as well and grade the evidence on it. But you can read over that list if you just pause the video if you need to. A good way to break down study designs is either between a descriptive and analytic um, designs. Descriptive designs could be surveys or cross-sectional studies, qualitative research, case reports, or case series. Analytic is where you're actually starting to do some sort of statistical analyses above and beyond just simple, what we would call descriptive statistics. You can have experimental type designs where there's maybe parallel groups, crossover studies, or even factorial designs. Or you can have observational studies, which might be a cohort study, a case control study, or a cross-sectional study. And we'll talk about those here in a moment. How do we classify study designs? First question you can ask is random assignment used? If yes, then it's probably some sort of a randomized controlled trial or a true experiment. If not, then you have to ask, is there a control group or multiple measures? If yes, then it may be what's considered a quasi-experimental design, which just means it's sort of like a true experiment, but it lacks one or more of the controls or characteristics of a randomized controlled trial or a true experiment. If not, then it's a non-experimental design. So what's an RCT, or randomized controlled trial? These are clinical trials. These are research studies that explore whether some sort of a medical strategy, treatment, or device is safe and effective for humans. And there's some principles of RCTs: randomization, allocation, concealment, meaning when you read a manuscript, many times they'll talk about that they don't know what group assignment they were um, in many circumstances. Blinding, meaning that maybe the subject was blinded. Double blinded means that the subject in the researcher or the data collector was blinded. Or triple blind was where you might have the patient, investigator, and a statistician were blinded to their group assignments. They usually have a control group. They also will have an adequate sample size based on a power analysis, and they have a clear description of withdrawals and loss to follow-ups. And there's a number of different types of randomized controlled trials. Most commonly, they're looking at efficacy, but there's some can be effectiveness trials, superiority versus equivalence trials, and then there's even phase 1, 2, and 3 drug trials. So what is efficacy? Efficacy is does the intervention work and who actually receive it? As opposed to effectiveness trials is how does the intervention work in those who it offered to. And when you read Dr. Biddle's, the chapter in Dr. Biddle's book that we have listed for this week's readings, he talks in a little bit more detail about the differences between those two. Something else that you may come across in the anesthesia literature is most commonly we do superiority trials, but we also do, you'll see something about equivalence trials. There's even another term called non-inferiority trials. But superiority trials is a treatment is different or better than a placebo or an existing treatment. This is what we're most commonly familiar with, is say in postoperative nausea and vomiting trials. Maybe we're looking at to see if a new drug is better than an old drug. Whereas equivalence trials, we're trying to, our analysis is set up in such a way that we're trying to determine that the new treatment is no worse than the active control. So say if you take a PONV study and maybe you have a new drug, say when Anzamet came out, and they want to say that it's just as good as ondansetron. And so maybe they set up their analysis and design as an equivalence trial to say that the difference, that we're not looking at differences, but we're trying to say that it is no worse than the other, that Anzamet is no worse than Zofran. Here's an example of a randomized equivalence trial that looked at iGels and LMAs in children. And so what they did was compared the iGel with the Supreme in children for routine airway maintenance. And what they concluded was that, let me get my pencil here, sorry. Oh, let me go back. So they say here is that it can be useful as an alternative. What they say here, there were no differences in time for device insertion, fiber optic view, airway complications. So basically what they were saying is that, so what you see here is that they're basically demonstrating that they were equivalent between the groups. Here's, if you wanted to read a little bit more on equivalence and non-inferiority testing in anesthesia, you can look at this, but this is a nice figure that shows you, here we have what's called a 95% confidence interval, and we'll talk about that a little bit later, but basically it's a common precision measure reported in the literature where you might have a mean and the 95% confidence interval, meaning 95% of the time the result is going to fall within that 95% range. So the first one shows a superiority where if we have zero, if you cross over the zero line with the 95% confidence interval, then there's usually no differences between the groups. Whereas if we're looking at non-inferiority, you see how it's crossing over zero, so we don't want to actually see that difference. So here, say a treatment is superior to a placebo, and then if we say if in our null hypothesis is that there's no difference, and then with non-inferiority trials, T is non-inferior to S, and then there would be non-inferiority not found, meaning that there was some sort of a difference. And then equivalence, you can see here, T and S equivalent, and you can say equivalence is not found. So if you want to read more about this concept, you can take a look at this article. So what about randomized controlled? So looking at drug trials. A preclinical is where a trial is designed. Really, they're looking at the safety, toxicity, and pharmacodynamic and pharmacokinetic information of a drug. And then phase 1 is given to a small group of people to evaluate its safety and identify any side effects. A phase 2 is where it's given to a little bit larger group for further evaluation. And a phase 3 trial is where it's even given to a larger group to evaluate its safety. And the phase 4 would be where they have post-marketing studies that helps identify information that was not identified in the original trials of the study.